Hello people, good day. Today we are going to look at trigonometry problem as it involves three-dimensional shapes. Now, remember under three-dimensional shapes, we can use our SOHCAHTOA, we can use our sine rule, we can use our cosine rule. Anyone that works, that is what comes in. But in this case, we don't even have values. We only have 90 degrees. All we have are variables. We have the PQ. Length PQ is X. Angle PSQ is theta. Angle QSR is alpha. And then the totals also, they gave us also that RQ is equals to RS. That's what this notation means. It means that those two lengths are equal. Now they're asking us to show that RS is 2 times x over 2 times theta cos alpha. Now, how do we approach this? We start working from where we have more values to the section where we have less values. Now, we want RS, but in this triangle, only alpha was given. But in triangle PQS, we have x and theta given. So we start working from that section and build up more values that we can work with on the lower triangle. So let's go into this. So we say that in triangle PQS that was given here, because this lies on the horizontal plane, this is 90, this is 90. So we can use SOHCAHTOA here. So we have opposite over adjacent. Because if this is 90 degrees, this is a hypotenuse. Then this is opposite over adjacent. So if we are working with two sides, why did we choose adjacent instead of hypotenuse? Because we want to work closer to RS. So choosing hypotenuse makes no meaning for us. So we start working closer to our goal. So we start working towards this triangle. So we choose opposite over adjacent of the angle. And opposite over adjacent gives us time. Because it's 2. Remember, SOHCAHTOA is opposite over adjacent. So we can say that tan of theta is equal to our opposite, which is x, over our adjacent, which is QS. Which is QS. So to get the length of QS, our QS will then be x over tan theta. X over tan theta. So we've gotten our QS. We can work under this triangle. Another thing we need to note here is this angle. We call it angle RQS. Because these two lengths are equal, it makes this an isosceles triangle. And under an isosceles triangle, base angles are supposed to be equal. Angle opposite equal lengths. The angles opposite equal lengths are supposed to be equal. So it also means that this will also be alpha. So it's also equals to alpha. And our reason is angle opposite equal lengths. Or we can just say isosceles triangle PRQS. Isosceles triangle RQS. So with this, we have two angles here. We don't know the length of the side, but we've gotten the length of this. So we can use sine rule to work around RS. We can use sine rule because we have QS, we can also get R. Therefore, you can say that our angle QRS will be 180 minus alpha minus alpha. Our reason is sum of angles in triangle QRS. Sum of angles in the triangle sums up to 180, and that is where we got this 180 from. So all of them here, this plus this adds up to 180, and we can get this angle. So therefore our angle here will be 180 minus 2 alpha. 180 minus 2 alpha, that is that angle. Now let's use sine rule. We can use cosine rule, but it becomes a little bit more complex. Let's use sine rule. Having in mind that we need our RS. Having in mind that we need our RS, so the angle facing the length is what we went with. So here for sine rule, we have RS over sine of the angle facing the length. RS over sine of alpha is equals to, we have QS, so let's use it. QS over sine of the angle facing it. Remember, that is the angle QRS that we got as 180 minus 2 alpha. So it's sine of 180 minus 2 alpha. 180 minus 2 alpha. Now let's continue. Let's write this. Our QS is x over tan of theta. So now we can continue on this space. Remember here we are working on triangle QRS. Now what do? Let's substitute what we have and simplify. We have RS over sine of alpha is equals to our QS is x over tan theta. And then sine of 180 minus 2 theta reduction formula, simplify it. 180 minus anything is on the second quadrant of sine. So its sign is still positive, so that will give us sine of 180 minus 2 alpha will give us sine of 2 alpha. To give us sine of 2 alpha. Now let's simplify. Make RS a subject formula. We have RS is equals to x over tan of theta multiplying sine of alpha being divided by sine of 2 alpha. This is a little bit more complex, but we'll go on simplifying until we arrive at what they need. We don't stop until we get there. Now, our RS going forward will be, if we simplify this, we have in the numerator, we have x sine alpha over tan theta divided by, well, let me leave this sine alpha here because it does something for us. Sine alpha, this is double angle, sine of 2 alpha. 2 alpha is a double angle, so this can give us 2 sine alpha cos alpha. That's double angle identity. It gives us 2 sine alpha cos alpha. So in this case, sine alpha can cancel out sine alpha. We have cos alpha. So x over tan theta divided by 2 cos alpha. If we simplify, we then give us x over 2 tan theta cos alpha. If you don't remember your division, please revise. Remember that can be x over tan theta divided by 2 cos alpha over 1. And then when you change this division to multiplication, 2 cos alpha comes below, and that will give us that. So remember, this is the approach, and that has given us what we have. So remember, when they say show that, you can't start touching this. You use whatever you have here to solve and simplify and continue simplify until you get to that answer. Any other thing you do will be wrong. You simplify, the final answer will not have any mark allocation because it has been given. But they want to see all the steps and all the routes you took to get to that. And when you get that, you get your full marks. This is a popular matric or grade 11 question. Please go through it. Get similar questions and solve, and consult with me, and I'm willing and ready to support you and to help and answer your questions. Please remember to share, subscribe and follow my pages, and remain blessed. I'll see you.